Today, let's take a look at this LeetCode challenger problem, sequential digits. An integer has sequential digits if and only if each digit in the number is one more than the previous digit. Return a sorted list of all the integers in the range between low and high inclusive that have sequential digits. And the constraint says the low and high boundaries are between 10 and 10 to the ninth. We are given two examples here. In the first example, low equals 100 and high equals 300. Output is 123, 234. So how this output is calculated? So let's take a look. So the low boundary is 100 and the high boundary is 300. So we need to find all the numbers between 100 and 300, and their digits are sequential. So the first number gonna be 1, then 2, 3, right? We can have 1, 2, 3, 4 because that number will be greater than the high boundary is 300. Then our second number will be 2, 3, 4, right? So can we have 3, 4, 5? No. This will exit our high boundary. Okay. So this is how the first output is calculated. Let's take a look at the second example. So the low boundary is 1000 and the high boundary is 13,000. Okay, so similarly, we start from 1000, and in order to have sequential digits, the first number will be 1, 2, 3, 4, right? And then we have 1, 2, 3, 4, 5. So this number is still less than 13,000. And then we have 2, 3, 4, 5, and there 3, 4, 5, 6, and then we have 4, 5, 6, 7, and then 5, 6, 7, 8, and eventually we have 6, 7, 8, 9, right? So we have 7 numbers. Okay, so one thing that we need to keep in mind is we are expected to return a sorted list, which means the numbers need to be sorted in ascending order. So in the second example, 1, 2, 3, 4, 5 should be the last number in the result list. Okay, so how can we solve this problem? So I think there is a pattern here, right? It's very obvious as the problem description says all the digits are sequential for a given number. So if we treat these numbers as streams, what we can see is it's going to be a substream of such a stream, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? If we treat any satisfying number as a stream, and that stream will be a substream of this stream, right? So the problem now can be converted to, we need to find the substream of this big stream, and when we convert the substream to integer, the value gonna be between the low boundary and the high boundary inclusive, right? And also from the low boundary and the high boundary here, we can know the length. Like for example, in the first example, if we treat the numbers as streams, the length of the streams will be 3. In the second example, the length could be 3 and it could be 4, right? And also we can leverage this length of stream, right, length to sort our numbers in ascending order, right? I made a mistake, so the length could be 4 and could be 5, right? The number has 5 digits should be larger than the number which has only 4 digits, right? So an idea here is we just start from each length and try to find all the substring. And then we convert the substring back to integer and check whether the value is between the range. If it's the case, we just add it to our result, otherwise we continue, right? So that's going to be our idea. Let's implement it. So let's first define a list. Okay, and for convenience, let's get the length. Okay. Okay. And now we just check length by length, right? And for each length, we check from the first digit, the most significant digit, right? Which, in another word, we start from the leftmost digits. But where we should stop? Let's say we are at here, I. So digits 9 should have index A, right? So A minus I plus 1 should equals to length. So I is 9 minus length. Okay. So I equals 0. I, let's so equal 9 minus length and I plus plus. Now we just need to get the substring and then convert it to integer. We need to define a string here. Let's call it a number. The number will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And the number dot substring. We start from I, length, and we convert this one to integer. Now we check if this number is between low and high, inclusive. We add it to result. Right, we just keep doing this until we find all the numbers. So eventually return the result. Okay, let's compile the code. It's not right. Okay. what's going on, and we get the length, and let's print out the number. Oh, okay, interesting. So for I, we start from the smallest length. Sorry. Yeah, we should include the maximum length. Yeah, and let's try to use another test case, 1000 and 13,000. 1000 and 13,000. Okay, seems it works. Okay, accepted. So let's see the details. Okay, I can see the percentage result. That's fine. So what's the complexity of this solution? So basically, we implement a solution that has two levels of nested loop, right? And for the outer loop, the length is starting from 2, right? And the maximum length we have is 9, right? For the inner loop, the worst case is we start from index 0, and then so the minimum length is 2, so I is less or equal to 7, so 0 to 7. So worst case we the inner loop, yes, we execute 8 operations, right, for each, and in total it's going to be 8 times 8, which is 46. So it's actually a big O1 solution. Interesting. Okay, and how about the space complexity? The space complexity, basically we need to know the maximum number of values we store in this list, right? And for length 2, we have 1, 2, 2, 3 until 89. So we have 8 numbers. For numbers that have length 3, we have 1, 2, 3, 2, 3, 4, to 7, 8, 9. So we have 7, right? And the maximum length we can have for a number is 9. So we only have one possibility here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So as we can see, it's an arithmetic sequence, right? So it's gonna be 2, and then we have a times a plus 1, which is 36, right? So time complexity is big O1 as well, because we have at most 36 data number will be stored here in the result. Okay, so this is one solution, and can we use other solution? Because when I go through these examples, I can see how these numbers are built. In another word, I think we can build these numbers on the fly. What does that mean? So, for example, so let's say our first digit is, let's just say it's 1, right? So the next time we're gonna append 2 at the end, right? And next one we're gonna append 3, right? For number that start with digits 2, what we do is we basically append 3 at the end, and then we append 4, right? So etc. So this is like is this a tree? Yeah, it's like a tree, right? It's like a tree, and we can have 7, we can have 8 here, and we can have like 9, right? But essentially this is look like a tree structure, and we can use BFAs. We traverse these numbers level by level, iterate these numbers, right, level by level, and when we go to the next level, we just append a new digits at the end, and this new digits will be one more than previous digit. So this is gonna be a BFA's solution. Okay, let's just code it. Let's reset, and first thing, let's define a result list. And then since we're gonna use the BFAs, and we need a Q. Q will be this one. Okay, we first start from the single digit. Okay, then we iterate the queue level by level. Iterate the tree level by level. In current DQ. And we check whether this number is within the range. If yes, we add it to the result. Right, and now we need to append a value, right, to the end, and that digits should be 1 greater than the previous one. So we first need to get the previous digit. To get the last digit. And then our new digits will be, let's call last digit, will be prev digit plus 1. Okay. And we need to check if the last digit is between 1 and 9. We append it to the current value, right? and then we add it to our queue. Right, eventually we return the result. Let's compile the code. Works. Let's try another one. 100 and 300. Yeah, seems like the BFA solution also work. Yeah, accept it. Okay, that's it.